I'm Raj Bala. I have attended a lot of these recently. I wasn't at the last one, but I went down this deep rabbit hole recently, and my immediate thought was, I got to show this at AI Tinkerers. So I'm going to take you guys down this same rabbit hole with me. So some of you might know that I operate an agentic RAG service. And what you would expect in an agentic RAG service is to be able to choose an embedding model. So I support tons of different embedding models. I support OpenAI's, I support Google's, I support Gina and Cohere and so forth. So I spend day in, day out looking at embedding vectors that are generated by an embedding model. The difference between an embedding model and an LLM generates text, right? You enter a question, LLM spits out text. With an embedding model, you enter text and it spits out an array of floating point numbers. That's what essentially what an embedding model does. And they're somewhat nebulous. So an embedding vector looks something like this. So look at this floating point, or this list of floating point numbers. That is an embedding vector. But they're really tough to visualize because it's just a list of floating point numbers, right? And this is where the rabbit hole begins. I started thinking to myself, how can I visualize thousands of these embedding vectors, and how can I make sense of what they do? So the thing that you do with RAG is you use distance metrics like cosine to find the similarity between one or more between two or more embedding vectors, right? So you've got two embedding vectors that are a list of floating point numbers. You run this algorithm that's called cosine similarity that measures the distance between these, the angle that these vectors, and it spits out a similarity. It says, yeah, these vectors are similar or they're not, right? So then I started thinking, I want to be able to visualize these embedding vectors, but I want to do it in kind of a fun way, not just a simple graph that you can plug into Excel. So I started thinking about this website that came out in 2005 called the $1 Million Homepage. You guys familiar with this? So the idea is for $1, you could buy a pixel. He was selling 1 million pixels, and that's why it's called $1 Million Homepage. Lots of gambling companies and lots of other somewhat nefarious companies bought pixels on the $1 Million homepage, and he made $1 million. So I started thinking, okay, well, what could I do that was kind of playful like this, allowed me to visualize embedding vectors and do it in sort of an homage to the $1 Million homepage. So you might be able to guess, I created something called the $1 Million Vectors. And what it is, it takes content that you enter, it generates vector embeddings, stores the vector embeddings, and then I take those vector embeddings. Well, first I take the content and generate this kind of fun image. There's this fun image that ends up being unique to every site. But this is where the rabbit hole begins. So I started thinking, okay, what would the user experience be like trying to navigate between these embedding vectors? And I thought Google Maps is exactly what I should do. So what I created was essentially a Google Maps-like experience to navigate embedding vectors. And this is, I mean, I went really deep on this, so excuse me if this, I'm going to take you down this rabbit hole, but essentially, I'm going to first create, hang on a second here, I can't see it all. I'm going to create a piece of content. So each of these embedding vectors, I call them islands. So it's a semantic island in a sense. So I'm going to create a new island for AI Tinkerers. I basically have a description, I have a title, I have this island content, okay? So I'm going to create this island, and what's going to happen on the back end, it's going to create this process, this queue function on the back end, where it takes that content, it's going to generate the embedding itself. But if I show you what it's like on a map, because it's kind of computationally expensive to do all this, it's kind of computationally expensive to do all this. What happens is this this AI Tinkerer's island that I just created, it gets placed, hang on a second here. It gets placed on the map next to what I call a volcano, right? So this is deep in the rabbit hole at this point. So a volcano, what does a volcano do? It erupts and it creates new land masses, right? It erupts, the lava hits the water and it turns into a landmass eventually. But so what I'm doing here is I'm creating this landmass, placing it next to a special spot called a volcano. Then what I'm doing is I'm taking this large vector embedding, which is 1,536 dimensions long. But to be able to map it, I've got to actually take it and make it a two-dimensional array. So I'm using this thing called UMAP. So UMAP is this mathematical thing that takes high-dimensional arrays and converts them to two-dimensional arrays. So I'm doing this for all this content. I've got all this content that I've added for things like OpenAI and for Anthropic. And then what I'm doing is, this is the deeper into the rabbit hole. I'm showing users the distance between OpenAI and other semantically related islands using cosine similarity. So essentially, when you're using this interface to say, what is similar to OpenAI? Well, it says Anthropic is the most similar thing, and it's entirely based on the vector embedding that gets generated from this description. So it's this description that I enter, generates the vector embedding, it ends up running this thing called UMAP on all the vectors, and then places this content on this Google Maps-like interface close to other islands that are similar semantically to this particular piece of content. That is my rabbit hole. So it's kind of crazy. I think I went crazy for a few days, working with this and building it. But I went so far to say, okay, well, how do I actually use this in an interesting way? Well, I noticed something really, really kind of mind-blowing to me. So because I could visualize all of these semantic islands on a map now, I began to notice that there was a cluster of islands that always stuck together. So it was a cluster of islands that should not be close to each other. So for instance, Amazon Web Services was really close to this other island I had on there for like Dell EMC. And that really shouldn't be the case. One is a cloud company, the other sells personal computers and servers and that sort of thing, right? So I dove in to figure out why. Why is there this cluster of islands that are really, really close to each other? And I found something that's absolutely alarming, to me at least. In the RAG space, it was really alarming. So what I found was that the structure of the description that I gave to Amazon Web Services and to Dell were identical. The structure. The content was very different, right? Because they're two different companies. But I had a paragraph, 3 bullets, a paragraph, and then like a second paragraph. And the vector embedding said, because the structure was similar, they're semantically similar, which is wrong, right? It's wrong. So what I did was, to validate that, I did like anything anyone else would do. I ran a ton of tests. And I found there are some models that find similarity based upon not the contents, the semantic contents within the content, but just because I've got 3 bullets and 2 paragraphs, it says, yeah, these things are 20% similar. Any guesses as to who the worst offender was in terms of embedding model vendor? Any guesses? OpenAI. OpenAI was the worst offender. I tested basically all the leading models of the embedding models in the list that I showed you. And OpenAI, the worst of all of them. The best, in fact, was from Voyage. So Voyage is a MongoDB thing. They've got this embedding model that is like 32,000 tokens long. It's a great embedding model. It's pretty reasonably priced. And I found it to perform the best. So that is the rabbit hole that I dove into. Happy to answer any questions. Hopefully this was interesting, as mind-blowing to me, or to you as it was to me. Yes. It's a good question. So his question was this. His question was, there are a number of different ways in which you can go from a high dimensional array. So in my case, it was 1,536 dimensions to 2 dimensions. So how do you go from that many dimensions that has that much semantic meaning built into that large array? How do you go from that to 2 dimensions? So this gentleman mentioned a couple of different approaches. So one is this thing called PCA. I actually wrote a blog post on this very subject, and the blog post says why I chose UMAP versus PCA. So effectively, PCA is this thing, I forgot what the acronym stands for, but it's kind of a blunt instrument to take a high dimensional array down to 2 dimensional arrays. So it'll just flatten everything. And that's not great because I wanted to maintain the semantic neighborhoods between these islands. So I mentioned earlier that there was this computationally expensive approach that I took, and it is the UMAP approach. So UMAP has to see all of the vectors at the same time, and it then squashes everything down using this really complex algorithm to go from 1,536 dimensions to 2 dimensions so I can put it on a map. But because it's so expensive, I have to do it offline. Well, not offline, I have to do it as in a queue function in the background. But because I chose UMAP, it maintains that neighborhood in spite of going from 1,536 dimensions to 2 dimensions. So that was a great question. Yes, sir. Yeah. No. So the question is this. It's a very good question too. So the question is, if I take the same content and I put it through 2 different embedding models, can we compare them? And the answer is no, because they're sort of proprietary between themselves, right? So the embedding vectors that get generated by embedding model A, it might be the same length, but you cannot just mix those 2 things in the same database. If you did that, you get awful results. I've done it accidentally, and you get awful results. But yeah, you cannot mix and match embedding vectors from 2 different models. It's a good question. So the question is, how do you have sort of cross embedding model vectors? Yeah, yeah. So the really simple approach would be to, I mean, the way RAG works essentially is you take the input query and you generate an embedding vector from that query, and you use that to search the database that contains the embedding vectors, right? So in theory, if you needed some sort of gateway between 2 dissimilar databases with dissimilar vectors, you would have to have some approach where you took the same query, created an embedding vector from both models, and then queried both of those simultaneously. I mean, it would be ugly, but that's ultimately what you'd have to do today. Yes, sir. Yeah. 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 So it's Jayesh, right? Is that? Yeah. So Jayesh asked this question of, have I found anything from my own experience that conflicts with the evals that people have done? Is that kind of the question? You know, I don't pay attention to the evals, frankly. I don't pay attention to them. I see blog posts on them, and I just kind of ignore them because I just rely on my own experience and what I find. And I don't think really, I mean, I haven't seen anyone say OpenAI is kind of crap for embedding models. I mean, no one's really said that, but if they did, I would be interested in seeing that kind of thing. Yes, sir. Yeah. Yeah. Yeah, the gentleman was basically saying that that this topic, this concept is being applied not in a Google Maps thing for content islands, but in something much more important. Yes, yes, yes. Um, I just want to show you one thing. So I wasn't able to bring it up just in the moment, but so here I have the volcano. So the volcano is like a special place in this application. It has to be where everything lands initially because UMAP has to run every hour. So I kind of just throw everything next to the island, and then when the queue function runs every hour, so actually at 8 o'clock it ran. Um, it will then take the embedding vector, it takes the embedding vector, downloads the fitted model that's already stored, applies this new embedding vector to the fitted model, and then places it on the map where it needs to be. But the volcano is this conceptual place I came up with as a place where everything starts out, because that's what volcanoes do, right? They erupt lava. So, yeah. Um, yes, ma'am. So it's a very good question. So the question was this. The question was, did I think about doing this in 3D instead of 2D? And I actually started with 2D. I started with 3D, but it was just really hard to get this 3D thing with this experience. I wrestled with it for a few days and eventually gave up and said it was going to take me too long. So I went with the simplest approach, which was 2D. Yes, sir. Yeah. Oh, gotcha. So the statement was essentially that three dimension in this cellular biology space essentially could leverage an additional dimension to give another representation to the embedding vector, essentially. One last question. Yes, sir. Yeah. So the question was this. The question was, this gentleman also works in RAG, and he hasn't found anything that's great at visualization. Yeah. So the question was, am I aware of anything? I'm not actually. So I started to do some digging onto what other things are there, and I just haven't really found anything. Certainly nothing as playful as a Google Maps visualization with islands and volcanoes. Okay, I think I'm being given the curtain call, so maybe we'll chat afterwards. Thank you, everyone.